Hello friends, in the previous tutorial we discussed about Python variables. Now let us discuss various operations that we can perform using Python operators. As you know, operators are responsible for a particular operation between two variables or operands. Python operator is a symbol that performs an operation on one or more operands. Python provides a variety of operators like arithmetic operators, comparison operators, assignment operators, etc. Let us understand each of them one by one. Let's begin with arithmetic operators. Arithmetic operators are used to perform arithmetic operations between two operands. It includes addition, subtraction, multiplication, division, etc. Let us initialize two numeric variables a and b with values say 10 and b as 3. If I want to add these two variables and store the result in another variable, say variable c, I can do it like this. This is called addition operation, and this symbol having plus sign is called addition operator. Similarly, you can perform subtraction operation, multiplication operation, and division operation. Here you can see division operator provides result in decimals when available. There is no separate provision for knowing about remainder or quotient. In scenarios where we need only remainder, we can perform remainder operation like this. So here you can see the output 1, which is remainder if you divide 10 by 3. If you are interested in only quotient of the division, then you can use floor division, which provides the quotient of the division after removing the decimal portion. This is how we can do floor division using double forward slash symbol. The result is 3, which is as expected. Now let's talk about another Python operator, that is comparison operators. Comparison operators are used to compare the value of two operands. Comparison operators always return in Boolean, that is Boolean true or false accordingly. There are many operators to check if a variable is equal, larger, larger or equal, smaller, smaller or equal in comparison to other variable. Let us initialize two variables a and b again with some value, say a as 10 and b as 15. And now let us perform few comparison operation. If I want to check whether a is greater than b, which gives me false. That is correct. If I reverse the operation, it gives me true. Likewise, you can check for other operators. These are very easy to understand. Now, let us talk about another operator, that is assignment operators. You have already understood many examples of these operators. In the previous illustrations where we declared any variable, say name employee or age employee, and passed any value to them, be it string or integer, or these variables a as 10 and b as 15, all are examples of assignment operation. The moment you declare and initialize a variable with any value, you automatically perform assignment operation. Python provides us the facility of multiple assignment. We can initialize multiple variables with same or different value. Suppose I have three variables, say A, B and C, and I want to pass a common value to them, say 5. I can use multiple assignment like this. So here you can see all the variables A, B and C are initialized with value 5. I can also store different values in these three variables simultaneously using this syntax. This is how we can assign same or different values to multiple variables in Python. Python also provides the facility of joint arithmetic and assignment operation. If I initialize a variable, say d with value 10, and perform this operation, d plus equals 10. So here you can see output as 20. If I break this operation in parts, I can write it like this. In this joint operator, left symbol represents arithmetic operation and right symbol is responsible for assignment of final result to variable on left hand side. After assignment operators, let us discuss logical operators. Logical operators are mainly used in the evaluation of an expression to make a decision. Python supports three logical operators: AND operator, OR operator, and NOT operator. We perform logical operations on Boolean variables. Let me initialize a variable with value Boolean true and a variable b with value Boolean false. And if we perform logical AND operation over them, we get output as Boolean false, which is correct. A logical AND operator gives result true if both the operands have conditions resulting in true. If any of the condition fails, logical AND operation will give result false. While logical OR operation gives result as true if any of the operand is true. If both operands have conditions which fail or give false result, outcome of logical OR will be false. Now that we have discussed two logical operators, logical and logical OR, now let's discuss the third logical operator, that is NOT operator. NOT operator is negation operator. It is a unitary operator, which means it operates on one variable and negates its result. For example, if we perform NOT operation on variable A, which is initialized as false, it will change its value and outcome will be true. So this is all about logical operators in Python. Let's talk about another Python operator, that is bitwise operator. Bitwise operators perform bit by bit operation on the values of two operands: binary AND, binary OR, binary XOR, negation, left shift, right shift are some bitwise operators. Let's discuss few of them. If I again initialize two variables, say a as 5 and b as 4, how can we perform bitwise operation over them? Let me first write binary equivalent of these two variables. Hope you might be having idea of number to binary conversion. I won't go into details of that. Let me directly write the equivalent of these two variables. Number 5 can be written as 101 in binary, and 100 is binary equivalent of 4. If now you want to perform any bitwise operation, say AND operation, we can do it like this. And if I visualize the result and try to understand it, I can see a binary AND operation is similar to logical binary operation. It gives true if both operands are true. Here in binary operation, true is represented by binary 1 and false by binary 0, and hence a binary AND will give result as 1 if both operands are 1. If any of the operand is 0, it leads to binary 0. So here binary AND of 1 and 0 will give 0, and 0 and 0 will give 0, 1 and 1 will give 1, and final output will be 100, that is 4. Now let's check another operation, bitwise OR. This is the symbol of bitwise OR. If I run this piece of code and try to understand the result, a binary OR will give outcome as 1 if any of the operand is 1. If both operands are 0, then output will be 0. So here 1 or 0 will give us 1, 0 or 0 will give 0, and 1 or 1 will give 1. Thus, final result outcome will be 101, that is equivalent to number 5. This is how we can perform bitwise operations. You can check other operators on your own. Those are very simple to understand and used less frequently. Now let us discuss another Python operators, that is membership operator. Python membership operators are used to check the membership of a value inside a Python data structure. If the value is present in the data structure, then the resulting value is true, otherwise it returns false. There are two membership operators available with Python, in and not in. Let us understand membership operator with the help of an example. If we initialize a string, say var string with value Python, and if I check character P lies in this string or not, I can do it like this, which gives true, that is right. But if you check for any other character which is not in the string, the result is false, which is as expected. If you replace in by not in, the result is true. So this is all about membership operators. Now let us talk about next Python operators, which is identity operators. Identity operators are used to evaluate identities present at both sides of the identity operators. There are two identity operators, is and is not. Let us take a simple example to understand it. We have already initialized a string variable var string with value Python, and no need to tell that data type of this variable is a string. If I write an expression like this, type of variable string is str, that is string. It gives me true. That is correct. Similarly, if I replace is by is not, it will give outcome as false. That's how we can write other expressions as well to evaluate relationship between adjacent values of an identity operator. All these Python operators are widely used in decision making while building any logic. Now that we have idea of Python operators, we will discuss a very simple module, that is style or methods of providing comments in Python, in next tutorial. If this tutorial has enhanced your knowledge about Python operators, please like the video and share it with your friends. Do not forget to subscribe the channel to be notified about latest tutorial. Happy learning!